are two systems to explain how a person works. One was built by physicists, computer scientists, mathematicians for over the past 70 years. And the other one emerged from, I'm going to say this plainly, a mystical revelation in 1987. And they describe the same thing. I'm going to show you exactly why I believe that, and I'm going to use it using precise structural language. And by the end of this video, you'll understand both systems well enough to see why that convergence either means one of two things. We stumbled onto something real about how minds truly work, or the human pattern recognition system is so powerful it finds structure anywhere it looks. Either answer is fascinating. Now, before I say the words neural network again, I want you to think about a very boring question. Should I bring an umbrella out today? You already know the answer, and you knew it before you checked your phone. You looked out the window, you noticed the color of the sky, and you felt the humidity. You remembered that it rained last Tuesday when the sky looked exactly the same. And something in you said, yes, bring the umbrella. You didn't need to run a calculation or weigh all the pros and cons of this list bringing your umbrella out. A system inside you, a system built from thousands of previous experiences, just output an answer. And that system is what we're talking about today. A neural network is our attempt to build that process artificially, to go beyond simulation and actually reproduce it structurally in math. The basic unit here is a node. Think of a node as a single question the system can ask. In our weather example, it would be, is the sky gray? Is it humid? Is it Tuesday? Nodes are connected to each other, and some of these connections are strong. Like humidity really matters for rain, and some of these connections are weak. The day of the week barely matters. And these connection strengths are called weights. A neural network is just a lot of nodes connected by weighted wires. Here is the crucial distinction, though. Some of these wires are frozen. They were set during training and they don't change when you deploy the network. Others are alive. They can still update based on new information. Fixed wires give the system its character. Trainable wires give it its flexibility, and you need both. And the ratio matters enormously. Now, every network has a problem. The world is full of irrelevant information. If you're trying to decide about umbrellas, you don't need to know what someone across the city had for breakfast. A well-designed network learns to ignore the noise and rather attend to the signal. This is called, fittingly, signal-to-noise problem. And it's the central challenge of the whole field. Now, I want to show you a picture. This is an artistic rendition by yours truly of the body graph. It belongs to a system called Human Design. And I know, I can feel some of you preparing to close the tab because you've already decided what this is based off of the aesthetic. You think I'm going to bring out more crystals in addition to this one and this one? Or you think I'm going to, just start talking astrology on you. But for this video, I don't care about what Human Design claims. I care about what the body graph is and what it is structurally mathematically is a directed graph. We have 9 nodes, 24 channels, and a more elaborate one, 24 channels that can connect them, and 64 filters distributed across those channels. The description should already sound a little bit familiar. In human design, some of these 9 centers are described as being defined. They have consistent, stable output, regardless of what's happening around them. Others are open. They fluctuate, and they take on the color, so to speak, of whatever is in the room. In the language we just built with neural networks, defined centers are frozen. They're frozen layers, and open centers are trainable. The system has both, and it needs both. The frozen part gives you your character, and the open part gives you your capacity to be shaped and adapt to your environment. This is the same architectural distinction, named twice by 2 different traditions that did not know each other existed, okay? All right, so before we go further, a small thing that turns out to be not small at all are those 64 gates. And the 64 gates in the human design system is not some mystical number. They come from the I Ching. 64 different hexagrams, each composed of 6 stacked lines, and each line either yin or yang, broken or solid. So 6 positions times 2, or 6 positions, 2 possible states each. 2 to the 6th power is 64. This hexagram system is a complete, exhaustive enumeration of a 6-bit binary space. Nothing is missing, nothing is redundant, and every possible combination is present exactly once. Now, the architecture that sits at the foundation of neural network memory theory, the one the entire field of neural memory research is built on top of, is called a Hopfield network. And a Hopfield network operates on exactly this principle: binary neurons that are either on or off, and state vectors composed of binary digits. Energy functions defined over the complete space of possible binary configurations. So, not similar logic, the same logic. The I Ching had it 3,000 years earlier, though. I'm not going to make anything mystical of that. I'm just asking you to notice it. Now, come back to the body graph with me. A gate in human design here is a filter, a tuning, a particular kind of signal the system can attend to. And when 2 gates connect across a channel between 2 nodes, both of them light up, and you get what HD calls a defined channel, which is a stable, reliable signal pathway. In machine learning vocabulary, this maps onto weights, but not in the binary way you might first assume, because weights don't just exist as on or off, they exist on a spectrum. The connection can be strong, weak, or anywhere in between. So let me be more precise than the usual telling of this. A defined channel, both gates activated, both ends lit, is a strong weight. The pathway is fully saturated. It outputs a reliable, high confidence signal regardless of what's around it. You can trust the signal that comes through it. A single gate One end of a channel activated but with no partner on the other side is a weak signal. The sensitivity is there and the filter exists, but the signal doesn't complete the circuit. It fires only sometimes, inconsistently, and it's easily drowned out by stronger connections nearby. In HD language, this is experienced as the theme of the gate showing up kind of fragmentary, as a flavor and not a voice in itself. An open center, no activations at all, is a near zero weight on that entire processing unit. The node exists in the architecture, of course. It holds a position, but it contributes almost nothing of its own. It mostly just reflects whatever is loudest around it. Now, hold on to that last one especially. It matters more than it looks like it does right now, and we're going to come back to it. Okay. Authority as the loss function. Now, this one is really interesting. Every neural network needs something called a loss function. And the loss function is the signal that tells the network whether it's moving in the right direction. Whether the output is just produced was closer to correct or further from it. Without this loss function, a network can't learn, it can't navigate, and it drifts away or just stays stagnant. Human design has something called authority, both inner and outer. Today we're going to be focusing on inner. Inner authority is the body's internal signal for whether a decision is correct. This can be a guttural phenomenon within the body, something internal, a wave through the stomach region, or whatever have you. Different body graphs have different authorities, and which one you have is determined entirely which centers in the body graph are defined. That alone is already a striking correspondence, but here is where it gets really elegant. The most common authority of human design is called emotional authority. And emotional authority has a peculiar property, okay? It cannot be trusted to give you all data in a single point in time. You have to ride the wave out, through the high, through the low, through the hollow parts in the middle. And then you wait for the signal to be steady. Only then is its reading reliable. So, in reinforcement learning, which is one of the most difficult subfields of machine learning, there is a class of problems called non-Markovian reward functions. These are loss signals that cannot be evaluated at a single moment. The gradient is meaningless at any single moment. You need extended observation across time before the signal becomes trustworthy. So this emotional authority of HD goes beyond metaphor for a non-Markovian reward function because it's an actual description of it. Earlier, I told you to hold on to the idea of open centers and near zero weights. We're coming back to it now. Okay. But to do that properly, I need one more concept from neural network theory. In my opinion, it is the most beautiful one, and it's the one that holds the whole picture together. It's called an attractor basin. My attractor basin. Imagine an energy landscape, a surface with valleys and ridges. We can drop a marble anywhere on it, and the marble will roll. It finds a low place and it settles. That low place is an attractor, a stable state the system returns to no matter where it starts from. And the region around it, every point on the surface that would roll into that valley, is its basin. The Hopfield network I mentioned earlier, the one built on binary state vectors, stores its memories exactly this way. Each memory is a valley. And when you give the network a partial or noisy input, it doesn't search for the right answer. It rolls and it falls into whichever basin that input is closest to. The memory completes itself. And that is how a well-informed identity functions. A defined center in human design is a fixed point attractor. It represents a stable energy minimum the system reliably returns to, no matter how much the environment pushes on the open parts of you. The defined centers pull the system back toward their characteristic output. It's a dynamically precise poetry. And the full body graph is an energy landscape with a specific attractor topology, okay? The configuration of your defined centers, your channels, your activated gates, that is the geography of your valleys, where they are and how deep they run, how wide their basins reach. Two people with different body graphs have different energy landscapes, of course. They have different stable states and different susceptibilities, different places the marble can settle. Open centers, then, are flat regions. The shallow ground, the places in your landscape without strong local minima of their own. These. When external energy enters from a defined center in someone nearby, kind of like an electromagnetic phenomenon. From that energetic weather of a transit as well, it can temporarily pull the system toward a basin it doesn't natively occupy. This is the mechanism the HD tradition has been pointing at all along when it talks about conditioning. So usually it's a vague spiritual mojo kind of verbiage that talks about conditioning. But what I believe is the basin switches in a perturbed energy landscape. And yes, the transits, which human design are described as the movement of the planetary program continuously activating gates in the collective field, are time-varying perturbations to that landscape. The weather of the sky reshapes the ground you're standing on. But each individual body graph determines which perturbations you're sensitive to and how strongly they can pull you away from your native attractor states. So a transit activating a gate connected to one of your defined centers barely moves your landscape, but a transit activating a gate, like right here, in an open center can temporarily carve a new valley, and you will feel for yourself falling into it. Here's where we are. Two systems built centuries and disciplines apart that describe the same structural features of individual information processing. Fixed and trainable parameters. Emergent macro behavior from micro topology. Internal loss functions, regularization strategies, and distributional shift. I want to offer you two interpretations, and I genuinely don't know which one is right. Okay? So the first interpretation is that both systems stumbled onto something real. That individual humans do process information in literally architecturally distinct ways. That there are genuinely different loss functions at play in different nervous systems. And that the physics of cognition has a structure. And two very different kinds of investigations found the same structure by different routes. The second interpretation is about us, about about the human mind's extraordinary compulsion to find patterns. Both systems use these graphs and weights and signal filtering because graphs, weights, and signal filtering are shapes that pattern recognition produces when it turns inward on itself. We build neural networks that way because that's how we think. Human design found similar structures because it was designed by humans for humans, and humans keep finding themselves in everything they make. Even though, as a side note, Ra Uru said it came from a voice, but it came through his human mind and vocal cords and hand and life force. So I think the honest answer is, I don't know. And I think that not knowing is more interesting than either answer alone. I mean, the I Ching is a Taoist type approach in a lot of ways. It's the Tao I Ching by Lao Tzu. And there's a certain beauty in just flowing with things.